Okay.
Okay, so
Alec, do you
is
have a
the
question?
reason you asked us about concave up and concave down to figure out if it is a maximum or minimum?
Wow. That is the second derivative test for local extrema. Yes. I was just asking you because I want to make sure that you can put it all together. Points of inflection, relative maxes, relative mins, asymptotes. I didn't ask you about asymptotes yet, but that. And put it all together to sketch a curve without a calculator. I mean, so if you see x squared minus 2x plus 3 all over x minus 1, you have to be able to sketch that without a calculator. Find its extrema, find its points of inflection, find any asymptotes. But yeah, that is the second derivative test for, not for concavity. The second derivative test for extrema is you find where the first derivative equals 0. Plug those into the second derivative. And if the second derivative is positive, it was concave up, which meant it's a
Minimum.
yeah. It was, if the second derivative is negative, it's concave down, so it's a maximum. Neat. Oh, I'm glad we waited till till that was on.
I wanted to wait.
That was
so
cool.
I thought he was going to be a joke.
Bobby could hear it.
Yeah.
Yeah.
Sorry, guys.
They're disappointed it's calculus related. Okay. You guys want to say hi to Bobby?
Hi, Bobby.
Oh, they said hi to you yesterday, Marissa. I have to put that. I'll cut them both and put them up there. Okay. All right. So the mean value theorem is a theorem that's really important. You're going to see at least one question on the AP exam. I promise you. Just as much as I promise you do not belong in Calc 1 next year, I promise you will see a mean value theorem on the AP exam at least once, okay, somehow. And it's never going to say, use the mean value theorem. It's not going to say that, okay? So, two conditions need to be met, and then this is actually kind of common sense, and the picture helps, right? So we're talking about a function that's continuous over a closed interval from A to B. So here's my interval from A to B, and the function has no breaks in it, okay? And it's got a closed dot at A and at B because this is a closed interval, okay? It needs to be differentiable on the open interval from A to B, and this is super important too. So you don't see any breaks. You couldn't have anyway because of the continuity, right? And you don't see any cusps, corners. That would be the other places that it would be not differentiable even if it was continuous, right? So there's none of those little pointy things in here. So, and it doesn't matter, though, if it's differentiable at A or at B because that's an open interval. So at A, it could cusp off over here or hit a corner or something like that. Got it? Same thing at B. If those two conditions are met, then there exists at least one value C for which, and I gave you actually 3 values of C in this picture. Look at this. What kind of line would you say each one of these is? Yeah, tangent line, right? Yeah, these are all tangent lines at these x values, at C1, C2, and C3, okay? Those slopes, I'm trying to illustrate that they are all the same as this blue line. What kind of line would you call this line?
Secant line.
Secant line, yeah. How do you find the slope of a line with 2 points?
Y minus y over x minus x.
Yes, y minus y over x minus x. How do you find the slope of a tangent line? The derivative. So, you know the mean value theorem. Okay? Such that f prime of c, that's where we're going to draw the tangent line, equals the slope of the secant line from A to B. This is how, or why, or I don't know how to say it, but you could get a ticket, and I have seriously heard that this has happened to people. You can get a ticket on the turnpike. If you get on, say, in Cranberry, and you get off at, like, Allentown, and if you get off too soon, you get a ticket. Because your average speed between Cranberry and Allentown, if your average speed works out to be, and you know you could divide your distance divided by time to get your average speed, right? So if your distance divided by time is greater than or equal to like 80 miles an hour, then that means at least one point between Cranberry and Allentown, if not a steady, thing, you were going 80 miles an hour. Because your instantaneous velocity is going to equal your average velocity from Cranberry to Allentown. And they will. I have heard this happen. Like, I wish I actually knew somebody that could show me the ticket. But, yeah. So a turnpike guy will hand you a ticket if you get to an exit too fast.
Why don't they do that for all exits? Like,
I mean, I
because you go to Cranberry, and then what if you say you go to Monroeville, or if you go to
right. I mean, and I
Well,
just
you got
used
there
Cranberry
too
and that as an example. But yeah, they would. I mean, I think at any turnpike exit, you can get like slapped with a ticket if you get there too fast from your previous destination.
Better tell my dad.
there's no way.
Yeah.
Well, I had to go to a Westinghouse thing
Uh-huh.
last year.
Oh, yeah.
I was running late. My average speed had to have been 85 at least. 'Cause
Really?
I was going 90 most of the time
On the turnpike?
on the turnpike.
Then I
I
don't
was
know.
like-
Then maybe maybe I should
No,
Snopes this. Okay, what?
What if I use the easy pass? You don't see a person.
Oh, well, let me tell
Well,
you, you
that's
can
what
get
you-
tickets in the mail.
Yeah, you do
Not
get
that I
tickets in
ever
the
got one from the New
Wow,
Jersey
that was-
Turnpike
Or-
for
or
accidentally
running your
going through an
bus.
exit without paying.
Or running the bus stop sign.
I never got one for that, unless I just didn't check the mail. But yeah, school bus
Isn't
thing.
that just, don't they, whenever it says speed enforced by aircraft? don't they
I think that's
They
baloney,
take your-
malarkey, whatever.
Malarkey.
Yeah.
just-
I mean,
how
if you
fast
look up
you
and see
go.
a helicopter, then slow down. If you don't, it's not enforced by air. I mean, they
thought-
do
I thought
do
they
that.
were like drones.
If you go to
Ah.
Amazon.com,
Not like drop bombs like a drone. But like,
Oh, okay. I'm gonna put this on Edline. So I don't think. Do you want to write this all down now? If you're a writer downer, then just leave room for this, okay? Because I'm not gonna leave time for it, but you can leave room for it. This is stuff that you already know. Increasing and decreasing test for local extrema. Now this is the first derivative test, not the second derivative test. You find the first derivative, and then find your critical numbers, which means you're gonna do two things sometimes to the derivative. What are your critical numbers?
0 and 0 and 0.
Yes, good, right. So you're going to set the derivative equal to 0, and if possible, if it has a denominator, set that equal to 0 also. Put your numbers. I do a number line. You could do, like, if you read the book and you'd rather do a sign chart or some other way, that's fine. But I like to just see everything on a number line to see, put your zeros or your undefined numbers on there, and then pick numbers in between to test to see if they're positive or negative. Where f changes from increasing to decreasing is where f prime goes from positive to negative. That's where you have a local maximum, and then vice versa for the minimum. Okay? Which is what I was asking you earlier. Concavity, use the second derivative. You find f double prime, and you kind of would call these critical numbers, but technically they have no name. Okay, because it's the second derivative. But you set your second derivative equal to 0 and you make it undefined. Use these values on a number line to determine your signs. And again, where f changes from concave out to concave down, that's a point of inflection. And that would be where f double prime changes from positive to negative. Again, and vice versa. Okay? So leave room for that if you want to write it